In this video, I will be solving O-level additional mathematics from this book, chapter 3, exercise 3E, 1 and 2 long problems. To simplify these types of problems, we more or less have to apply these 5 rules of logarithm. So, let's begin. Here question 1 asks to simplify the following expression as a single logarithm. Question A, we have log 5 to the base of a plus log 3 to the base of a. So as we know from the product rule of log that the logarithm of a product is the sum of the logarithms of the factors. For example, if we have log m times n to the base of a, then we can write it log m to the base of a plus log n to the base of a, or vice versa. Here m and n are the argument of the log and a is the base. So applying product rule of log, we can write this expression as a single log like log 5 times 3 to the base of a. Here 5 and 3 both are the argument of log. So 5 times 3 it will be 15. So finally we will have log 15 to the base of a, and this is our final answer. In question B, we have log 35 to the base of a minus log 7 to the base of a. As we know from the division rule of log that if there is a log m over n to the base of a, then we can write it log m to the base of a minus log n to the base of a, and vice versa. So following this rule, we can write it as a single log 35 over 7 to the base of a. So if we divide 35 by 7, then we will get 5. So finally we got log 5 to the base of a, and this is our final answer. Here question C, as like question A, we can write it as a single log 5 times root 5 to the base of a. So 5 times root 5, it will be 5 root 5. Then we got log 5 root 5 to the base of a, and this is our final answer. Here question D, we have 2 times log 3 to the base of a minus log 4 to the base of a. So first of all, we should remove this 2, then it will go to the power of 3. If without removing 2, we cannot apply quotient or product rule. So if we send this 2 to the power of 3, then we will get log 3 square to the base of a minus log 4 to the base of a. Since we know from the power rule of log that m times log n to the base of a, then we can write it log n to the power m to the base of a. This is called the power rule of log. So here 3 square means it will be 9. Then we also have log 4 to the base of a. Now we can apply division rule here. According to the division rule, now we can write this expression as a single log like log 9 over 4 to the base of a. When 9 over 4 is an improper fraction, then we can write it as a mixed fraction like 2 whole are 1 over 4, and this is our final answer. Now come to simplify number E. Here question E, we have 3 times log 4 to the base of a plus 2 times log 8 to the base of a. First, we should remove the coefficient from the log, then it will go to the power of the argument. Otherwise, we cannot apply quotient or division or product rules here. So, if we send 3, it will go to the power of 4, then 2 will go to the power of 8. So 4 to the power 3, it will be 64, and 8 square, it will also be 64. So according to the product rule, we can write these two logs as a single log, like log 64 times log 64 to the base of a. So here 64 times 64, it will be 4096. Question F, we have 2 times log 5 to the base of a plus log 4 to the base of a minus 2 times log 3 to the base of a. So first we need to remove coefficient from the log, then we can write it log 5 square to the base of a plus log 4 to the base of a minus log 3 square to the base of a. Just we have removed the coefficient and it will go to the power of the argument. So here 5 square means it will be 25. Then we also have log 4 to the base of a minus 3 square means it will be 9. So here we have 3 logs with the same base a, and they are with the addition and subtraction relation, so that we can write it as a single log, like log 25 times 4 over 9. So 25 times 4, it will be 100, and in denominator we also have 9. So when 100 over 9, it is an improper fraction, then we can write it as a mixed fraction, like 11 whole jar 1 over 9. So finally we got log 11 whole jar 1 over 9 to the base of a. In question D, here also we have 3 times log. So first we need to remove these 3 from the log, then it will go to the power of 5, and we also have log 25 to the base of 6. So 5 cube, it will be 125, then we have minus log 25 to the base of 6. Now according to the division rule, we can write it as a single log, like log 125 over 25 to the base of 6. So if we divide 125 by 25, then we will get 5. So finally we will have log 5 to the base of 6, and this is our final answer. Here number 8, we have log 21 to the base of 2 plus log 3 to the base of 2 plus minus log 5 to the base of 2. So here we have 3 logs with 2 relations. First one is plus and second one is minus, so that we can write it as a single log, like log 21 times 3 over 5, according to the product and quotient rule. So if we here 21 times 3, it will be 63, then in denominator we also have 5. So here 63 over 5 is an improper fraction, so in mixed fraction we can write it 12 whole jar 3 over 5, and this is our final answer. Here question 2 asks evaluate each of the following without using a calculator. Question A, we have two logs with subtraction relation with the same base. So in a single log we can write it log 6 over 2 to the base of 3. So if we divide 6 by 2 it will be 3. So finally we will get log 3 to the base of 3. As we know, when the log and base are same then it will become 1. So finally the answer will be 1. Here question B, we have log 5 root 5 to the base of 5 plus log root 5 to the base of 5. So according to the product rule of log, we can write it as a single log like log 5 root 5 times root 5 to the base of 5. So here 5 root 5 times root 5 it will become 25. Since root 5 times root 5 it will be 5, then 5 times 5 it will be 25. So finally we will get log 25 to the base of 5. So instead of 25 we can write it 5 square since 25 is a square number. So here the power from the argument we can take it as a coefficient of log, then we can write 2 times log 5 to the base of 5. So here log and base are same, then this log will be 1. So finally we will get 2 times 1 it will be 2. Here question C, we have log cube root 5 to the base of 5 plus 2 times log root 5 to the base of 5. So first we should remove the coefficient of log, then it will go to the square of the argument. So instead of cube root 5 we can write it 5 to the power 1 over 3, and we have to remove this 2, then it will go to the power of the argument, it will be root 5 square. So according to the power rule of log, we can take the power as an coefficient of log, then it will be 1 over 3 log 5 to the base of 5 plus here we have a square root 5 square, then a square and root it will be cancelled out, then finally we will have only 5. So here we have 1 over 3 and here log 5 and base 5 both are same, then it will become 1, and this log also will be 1. Since as we know when there is a log a to the base of a, then it will be 1. So here we have 1 over 3 plus 1. If we add 1 over 3 plus 1, it will become 3 plus 1 over 3 means it will be 4 over 3. When this is an improper fraction, we can write it as a mixed fraction 1 and 1/3. Here question D, we have log 5 to the power 4 to the base of 5 minus log 1 over 4 to the base of 16. First, we should take the power from the argument so that it will become the coefficient of log. Then we can write it 4 times log 5 to the base of 5. Because this power will come in front of log as a coefficient of log minus log, we have 1 over 4. Since the base is 16, then we should make the argument 16. So instead of 1 over 4 we can write it 1 over 16 to the power 1 over 2. But the question is that how can I write 1 over 4 to 1 over 16 to the power 1 over 2? Here I will show you the clear way. We have 1 over 4. Instead of 1 over 4 we can write it a square root of 1 over 4 to the power s square. So here s square and root will be cancelled out. Finally, we will get 1 over 4. As we know, 4 square means it will become 16. So we can write it 1 over 16 root square. Root square of 1 over 16. And we can write a square root as a power of 1 over 2. So finally, we will have 1 over 16 to the power 1 over 4. So now here we have 4 times log 5 to the base of 5. When here log and base same, then this log will become 1. Then we also have minus log. Here we can write 1 over 16 to the power 1 over 2 as 16 to the power minus 1 over 2. So 4 times 1 it will be 4 minus, here we have power minus 1 over 2, it will come in front of log, then we will have minus 1 over 2 times log 16 to the base of 16. Here now log and base are same, then it will become 1. Here minus and minus 1 over 2 it will become plus. So finally we have 4 plus 1 over 2. So if we add 4 plus 1 over 2, then it will become 8 plus 1 over 2 equals 9 over 2. When this is an improper fraction, then we can write it as a mixed fraction 4 and 1 over 2. Here question is we have log 64 to the base of 8 plus log 1 over 7 to the base of 7. Now we can write it log as 64, we can write it 8 square, as we know 8 square is equal to 64 plus log 1 over 7, we can write it 7 to the power minus 1. As we know, a to the power minus 1 equals 1 over a. So here we should take the power from the argument, then it will come to in front of log, it will become 2 times log 8 to the base of 8 plus, here minus 2 also will come as an coefficient of log, then we will have 7 log 7 to the base of 7. 2 times log 8 to the base of 8, this log will become 1, and here plus minus 1 it will become minus log 7 to the base of 7, this log will also become 1, then we will have finally 2 minus 1, it will be 1, and this is our final answer. Question we have log 12 to the base of 3. So we can write 12 as a factor of 4 times 3. As we know 4 times 3 it will become 12 plus log 4 to the base of 3 minus log minus 2 log 4 over 3 to the base of 3. We can write it 2 times log 4 to the base of 3 minus log 3 to the base of 3 according to the quotient rule of logarithm. This 4 and 3 will be the difference of the logarithm. So according to the product rule, we can write log 4 times 3 as log 4 to the base of 3 plus log 3 to the base of 3. We also have log 4 to the base of 3 minus 2 times log 4 to the base of 3. Then here minus 2 and minus this one will become plus 2 times log 3 to the base of 3. Here we have log 4 to the base of 3 plus log 4 to the base of 3. Then we can write it 2 times log 4 to the base of 3. And here we also have minus 2 log 4 times 4 to the base of 3. Here log 3 to the base of 3, it will become 1. And we also have 2 times log 3 to the base of 3, it will also become 1. So we will have 2 times 1. So here 2 times log 4 to the base of 3 minus 2 times log 4 to the base of 3 will be cancelled out. Then we will have 1 plus 2. So here 1 plus 2, it will become 3, and this is our final answer. Here question G, we have 2 times log 4 to the base of 10. First we should remove coefficient of log, then it will go to the power of the argument. So now we can write it log 4 squared to the base of 10 minus log 2 to the base of 10 plus log 5 cube to the base of 10, when this 3 will go to the power of the argument. So here 4 square means it will become 16 minus log 2 to the base of 10 plus 5 cube means it will become 125. So here we have 3 logs with the same base with two relations. One is subtraction and another one is addition. So as a single log we can write it log 16 times 125 over 2 according to the quotient and product rules of logarithm. So if we divide 16 by 2, it will be 8. Then 8 times 125, it will become 1000. So we got log 1000 to the base of 10. Instead of 1000, we can write it 10 cube. Since 10 cube, it will become 1000. So here first we should take this power as a coefficient of log, then it will become 3 times log 10 to the base of 10. Here this log will become 1, then finally we will have 3, and this is our answer. Now come to question 8. Here we have same basis of log with the addition and subtraction relation. So as a single log we can write it according to the division and quotient rules of logarithm. We can write it as a single log like log 27 times 14 times over 9 times 7 times 6. So if we calculate this argument, finally from the argument we will have log 1 to the base of 10. Since we know any log with the argument 1, it will become 0. So final answer will be 0. Here question I, we have 2 over 3 log 8 to the base of 3. So we can write it 2 over 3 times log 8 means we can write it 2 cube. Instead of 8 we can write it 2 cube, right? Because 2 cube it will be 8 minus 3 over 2 log. Here we have 16. Instead of 16 we can write it 2 to the power 4 plus 1 over 2 log. Instead of 32 we can write it 2 to the power 5. So here we have 2 over 3, and if we take this power as a coefficient of log, then it will become 2 over 3 times 3 times log 2 to the base of 2 minus 3 2 over 2 times 4 log 2 to the base of 2 plus 1 over 2 times 5 log 2 to the base of 5, because this 5 will come as a coefficient of log. So here we have if we divide 3 by 3, it will be 1. Here finally we will have 2 times here log 2 to the base of 2, it will be 1 minus, if we divide 4 by 2, it will be 2, then 2 times 3, it will become 6. So finally here we have minus 6 times 1 plus 5 over 2 times this log also become 1, since the both argument and bases are same. So finally we will have 2 minus 6 plus 5 over 2. So if we subtract and add these three values, finally we will have 4 minus 12 minus 5 over 2. So if we calculate it, we will get minus 3 over 2. Since it is an improper fraction, in mixed fraction we can write it minus 1 and half. Question J, we have log 10 over 9 to the base of 4 minus log 24 over 25 to the base of 4 minus 3 log 5 over 6 to the base of 4. So first we need to remove this 3 from the coefficient, then it will go as a power of 5 over 6 cube to the base of 4. Now we can write it log 10 over 9 to the base of 4 minus log 24 over 25 to the base of 4 minus log 5 cube means it will be 125, and 6 cube means it will be 216 to the base of 4. So here we have 3 logs with a subtraction relation with the same base. So according to the division rule of log, then we can write it as a single log, like log 10 times 25 times 216 over 9 times 24 times 125. So if we calculate this argument, finally we will get log 2 to the base of 4. So we need to make the base and argument same. So instead of 2, we can write it 4 to the power 1 over 2. So if we take this power as a coefficient of log, then we can write it 1 over 2 times log 4 to the base of 4. So when the base and argument are same of that log, then it will become 1. So finally we will have 1 over 2 times 1. Here question K, we have 3 logs with the same base with argument square root. So first we should remove this square root and write it as a power of the argument, minus log 91 to the power 1 over 2 plus log 52 to the power 1 over 2. Now we can apply division and product rules of logarithm. Then we can write it as a single log, like log 175 times 52 over 91 to the base of 10. Then we have also as a power 1 over 2 to the argument. So if we calculate 175 times 52, it will become 9100, and we also have 91 as denominator and power 1 over 2. So if we divide 9100 by 91, it will become 100, and we also have power 1 over 2. So instead of 100, we can write it 10 square. So here we will have log 10 square, and we also have power 1 over 2. So here 2 and 2 will be divided, then it will become 1. So finally we will get log 10 to the base of 10, and this log will become 1, and this is our final answer. Here question L, we have 4 logs with addition and subtraction relation with the same base. So we can write it as a single log applying the rules of product and division rules of logarithm. Then we will have log 4 times 32 times 9 times 105 over 15 times 7 times 4. So if we calculate this argument, from this argument finally we will have log 36 to the base of 6. Since 36 is a square number, so instead of 36 we can write it 6 square. So we will have log 6 square to the base of 6. Now we can take this square as a coefficient of log, then it will become 2 times log 6 to the base of 6. So here the argument and base of the log same, then it will become 1. So finally we will have 2 times 1, it will become 2, and this is our final answer. Thanks for your patience.